Okay, so yesterday we stopped with hyphen notation. Here's what I want you to do. I want you to take your periodic table. I want you to find, let me find something good here. Find radium. Find radium, write it in hyphen notation before we start with nuclear symbol. So find radium, write it in hyphen notation. Anybody struggling finding radium? Try group 2. It's an alkaline earth metal.
Wait, what is it? Radium. Oh.
Radium, not radon. Radium. What's the chemical symbol, Carter? Ra. And this number that I put after it, what's it called, Lindy? The mass number. What is that number, Lindy? Did you find it? You don't remember. 226. Okay. All right, so that's radium in hyphen notation. To be able to work with it, though, you have to know its atomic number. So there's another way that we write elements. This would be way 2 in your notes. And it's called nuclear symbol. So when I write nuclear symbol, we'll use radium again. You write the elements symbol at the top, like a superscript, you write the mass number. So this is mass number. And at the bottom, down here, like a subscript, I write atomic number. Then you have all the information you need to be able to do some calculations or figure some things out if you're given nuclear symbol. So I want you to look at your periodic table and I want you to find tungsten. Tungsten. When you found it, stand up. Caleb, help them out. What's the chemical symbol for tungsten so they can find it? W. See, in group 6. Group 6. Okay, this is what I want you to do with it. For tungsten, I want the following. See if you can do it, and then we'll check with lab partners. I want hyphen notation. I want nuclear symbol. I want number of protons, number of electrons, number of neutrons, and I want the average atomic mass. How about just get together really quick? I'll give you 2 minutes with your lab partners. See if you can do it, and then check with each other. Go. Try to do it by yourself and then check. If you're partnerless, join another group. Guess I should figure this out. When you've got it and you both agree, come back to your desks. Okay, raise your hand if you think you know what you're doing. If you feel pretty confident you're right. Okay, Annika, tell me hyphen notation. 184. Anybody not agree with that? Okay, give me a nuclear symbol, Addie. And 74. Okay. Emma, give me the number of protons. 74. Josh, give me the number of electrons.
I think I'm 74.
74. Kirsten, give me the number of neutrons.
110.
110. Isaac, give me the average atomic mass.
Wouldn't it just be 186? Or no, 183.
183 point what?
183.85.
Yep, you got to use the whole thing when it's average atomic mass. Okay, easy enough? All right, we'll do something that's just a tick more challenging then.
Oh, God.
All right, so let's talk about isotopes. And we'll do some calculating with those. First thing we need to know, I'm just going to go through some rules. If I find a pen that actually works. There we go. Okay. The first thing you need to know is all atoms of the same element have the same number of neutrons. No, sorry. Protons. So they all have the same number of protons, which means, what number tells me the number of protons? Which one of those? We've had three. Well, we've really only had two. Mass number and atomic number. Which one is defined as the number of protons? Okay, so this is really the atomic number. So I would say all atoms of the same element have the same atomic number. So that's the first thing you have to remember. Same atomic number. Second thing we have to remember, all atoms of the same element don't always have the same mass number. So they don't always have the same mass number. I'm going to let you write that, and then we're going to stop and think about it for a minute. If they don't always have the same mass number, but they always have the same atomic number, hear that again, if they don't always have the same mass number, but they always have the same atomic number, what's the thing that changes? Neutrons, yes. I was going to ask Mara, but okay. So the number of neutrons changes.
Fancy.
So let's look at this. I'm going to show you some things you can do with this. Let's use chlorine. We'll use 2 isotopes of chlorine. I've got Cl38 and Cl35. Now again, what's this number called that goes out here? Mass number. So these are mass numbers. And this is a mass number. Don't let it confuse you. They still both have the same atomic number. Without looking at your periodic table, what's the atomic number of chlorine? You should know that. Yes? 17. So chlorine is atomic number 17. It never changes. So if I take this and I say to you, find the number of protons, the number of electrons, and the number of neutrons, see if you can do that based on the information that I've given you. So we'll make this one chlorine 35, and I'll do another one for chlorine 38. Okay, who wants to read me their answers for chlorine 35? Who's got it? Josh.
So 35 is 17, 17, and then 18.
And 18. Stand up if you agree with him.
I think I agree with myself.
All right, good. Now here's my next question. Do you have 38 done yet?
Yes.
Yes? Carly, read me your 38. I haven't heard from you today. 17, 17, 21. Stay standing if you agree with that. If you don't, sit down. Okay, good. You got it? Easy enough? So here's a question you really have to think about this. Maybe, maybe not. Oh, if you could see it, it would be helpful. Which is the most common isotope? What do you think? Which is the most common isotope? See if you could figure that out. Anybody have any idea? Rowan,
35.
why did you pick that?
Just a little bit.
Yes, excellent. Look at them, and whatever is closest to what's on the periodic table is the most common. So it's chlorine 35. It's closest to what's on the periodic table. So whatever's closest, even if you have 8 of them, you pick the one that's the closest. I'm going to give you one more example to try. Let's work through this same process with, let me think of one. Oh, we'll just do a simple one. We'll use carbon 12 versus carbon 14. I want you to go through that, and I want, for both of them, electrons, neutrons, protons, and we'll do nuclear symbol, and let's see if you can give me atomic number of both, mass number of both. Is this an isotope? Is this most common isotope? See if you can work through it. When you're all done, stand up. Okay, Faith, will you read me everything that you have for carbon 12?
Yeah. Okay, for the electrons I got 6,
Okay,
and then that I got 6,
okay,
and then that I got 6,
okay,
and then for that I got C at the top 12, and then above 6, 6, 12, yes,
yes.
and yes.
Do we all agree with that? Yeah? Mara, you want to read me your carbon 14?
6,
Good. Yes, and what? No. Now, look at this. Is it okay to have yes and yes? Yes, 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 and yes. Why is it okay? I don't know. Because, I don't know. Maybe just because everything is an isotope. Everything. Everything's an isotope. So that's like a gift to you people. If I put that on Friday's quiz, that's my present to you. We are having a quiz Friday. It's little. It's little. Just over this stuff. Surprise! So you get a surprise and a gift today. Surprise, we're having a quiz. Gift is this an isotope? The answer is always yes. Okay? All right, let me show you one more thing. And then we'll do some, I'll let you do some practicing with your lab partner. So we have to be able to calculate when we're given a problem. Let me find one for you. Actually, we probably should get this definition down and then we'll do a problem so that you know what it is. Average atomic mass. I said it before, but we don't have a good definition. It is called the weighted, we'll talk about what that means. The weighted average of all naturally occurring atomic masses of the same element.
How do they even find the mass of an atom?
Very carefully.
Makes sense.
Take Chem 2, we'll learn about it.
Okay.
So this weighted average, you guys, that's kind of confusing. This weighted average means you're given, normally you're given a percent, and you have to turn it into a decimal before you can do the math. The percent takes care of weighting it, or takes care of the most common isotope being represented in the greatest quantity. I'll keep that straight today. So what you see on the periodic table, that average atomic mass, is the average of all of them I might go out and find. So now, I'm going to have you write this problem down really quickly. Can I move this one? Are we good? Okay, I don't know if this is going to work. Yeah. Put this problem in your notes. You can paraphrase it as much as you want, but be sure it's going to make sense when you go back to it. Okay, can I move this? Okay, put that up there. So I just kind of copied down the really important information. So first of all, let me tell you this. When you are calculating average atomic mass, whenever people hear that word average, they want to divide. You want to go, oh, I have two of them, I'm going to do my calculation, I'm going to divide by 2. You don't ever divide. This percent takes care of that for you. it tells you, or it evens out how much of this compared to how much of this, because it's not an even amount. So when I want to solve one of these, the first thing I do is I change the percent to decimal. I'm going to change my percent to a decimal, which is the same as dividing through by what? Mathematically, if you struggle with that. 100. So if you struggle with it, that's okay, but no, when you're changing a percent to a decimal, we divide through by 100. So this becomes what?
0.6917.
Exactly, and this becomes 0.62939. Okay? So now I have turned my percents into decimals. The second thing I'm going to do is multiply my average atomic mass by the decimal. And step 3 would be to add all parts. So let's do that. Let's see what that looks like when we set it up as an equation. So I'm going to do copper 63 first. I have my atomic mass is 62.939, which I multiply by 0.6917. So that represents my copper 63. And then I add to it my copper 65. I do the same thing. I take my 64.92773 multiplied by, where is it? I got the wrong thing written there. 0.3083. You guys didn't tell me. I didn't use percent. I don't know what that's supposed to be. So I do the math in each parenthesis and I add them together. You can do the whole thing in one equation on your calculator, or you can do it in parts. So let's do that. Put it in your calculator. Be sure you do parentheses plus the other set in parentheses if you're doing it all at once. When you think you have an answer, stand up. When you think you have a correct answer, I should say. Dang.
Oh, what did I do?
If it helps you to do do pieces, you can do it in pieces. It doesn't matter. Anybody having trouble putting it in their calculator? Nope, we're good. Okay. This is the test of if you can use your calculator correctly or not. Who have I not heard from today? I don't even know. Annika, tell me what you got. I don't know if I've heard from you or not.
Do we keep it in decimal form? Or do we like...
It should have a whole number with some decimals behind it. Okay, so Addie, what'd you get? Annika's doubting herself.
I think half my numbers were wrong, but 87.
Okay. Yeah, this is a problem. What'd you get, Rowan? 63.552, and I would call this AMU, and we'll talk about why later. That is actually a correct answer. Now, let's look at let's look at, oh, shoot, I'm gonna run out of time. Let's look at our, how do I know if this is correct? What could I do? Josh?
Check your periodic table.
Check your periodic table. People, find copper. Cu. Look at that. 63.546. So we're pretty dang close. If you're that close, then you know you're right. But let's look at the parts just so we can see. Let's put this in our calculator and see what you get. You guys who didn't get the 63 point whatever. Okay, so I'm going to put 62.939 times 0.6917, and here I get, you probably can't see this, 43.53, and it goes on. Did you get that part, girls?
I'm good now.
You're good now? Are you good now? Anybody who didn't get it, are you good now? Honestly, because if you get these wrong, it's like a big chunk on your quiz. Nobody wants to fail a quiz, right?
I do.
Josh. All right, so listen, we'll do a couple more tomorrow. I think I'm going to stop there. And then we'll go into lab. Probably Thursday, I guess. So listen, you're going to like this. Oh, shoot. I got to stop recording.